want you to try something. It's a thought experiment the book uses right at the start. Try to picture a single atom in your mind. Just one. Now imagine its journey. That one atom, which is itself almost all empty space, traveling across these vast astronomical distances. It might have spent millennia crushed inside a star, then wandered through empty space for eons, and now, right now, it's inside one of your cells listening to this. The sheer improbability of it all. It's just staggering, isn't it?
It really is. And that immediately sets the tone for the entire book. This idea that everything, absolutely everything we are, is made of these tiny building blocks that have been on this unbelievable journey since the very beginning.
Exactly. And speaking of expanding on things, we're trying something new with this deep dive. We want you to discover a new, in-depth approach to book coverage with this extended summary. So unlike our previous review, which was a more focused analysis, this feature is a really comprehensive overview. We'll be tracing the intellectual roots, the key arguments, and the real-world impact. If you appreciate this expanded format, please let us know. Your feedback will definitely help shape what we do in the future. Today, we are taking on Bill Bryson's phenomenal popular science book, A Short History of Nearly Everything, 2.0. It's just a remarkable piece of scientific history. It's so accessible, and it has this fantastic sense of humor, even with these incredibly dense topics.
Well, the core question that holds the whole thing together is what makes it so compelling. It's basically, how did we figure all this out? How did humanity, over centuries of trial and, well, a lot of error, arrive at what we currently think we know about the universe, our planet, life, and ourselves?
The scope is just enormous. From the Big Bang right up to us. And just a quick note before we jump in, you are experiencing a unique two-host AI conversation powered by Google's Notebook LM for deeper, more dynamic book summaries.
Structurally, the book is thematic. It starts at the absolute largest scale you can imagine, the cosmos, and it works its way inward, all the way to us, humans, and the risks we face now. But what really makes it Bryson is that he focuses on the human story behind the science. He's always using analogies and these amazing, sometimes hilarious stories of the actual scientists who made the discoveries.
Let's start there then with the very, very big cosmology. The book opens by tackling the sheer size and age of the universe, and it just hits you with these numbers that are almost impossible to comprehend.
Orders of magnitude that are just mind-bending. Bryson forces you to confront this idea that everything we can see, all the stars, all the galaxies, is less than 1% of what's actually out there.
And the rest is, what? Dark matter and dark energy.
Exactly. Mysterious stuff we can't see but we know is there. And this all ties into the development of the Big Bang Theory. He stresses this wasn't some sudden revelation. It was a fiercely contested idea for a long time.
Right. It took key figures, like Edwin Hubble, to provide the actual proof.
Yes. Hubble's observations gave us the evidence for an expanding universe. The incredible realization that space itself is stretching, carrying all the galaxies away from each other.
Yeah, in those very first unbelievably brief moments after the bang, that's when the first ingredients were made.
Precisely. The insane temperatures and pressures allowed for the first nuclear reactions, producing hydrogen and helium, the light elements. That was the raw material for everything else. Anything heavier, say the iron in your blood, had to wait for stars to be born, live, and then die, a process that took billions of years.
So from that cosmic scale, the book just pivots and shrinks right down to the atom. The shift is so jarring. You go from light years to, what, picometers? I mean, a picometer is a trillionth of a meter.
It's a scale that's almost meaningless to us. He uses that great analogy.
Right.
The nucleus of an atom is like a fly in the middle of a vast cathedral.
And the cathedral itself is the atom.
And it's mostly empty space. That's what's so counterintuitive about matter at this level. The book walks you through that history, from just philosophical ideas of indivisible bits to realizing atoms are these complex structures. And it touches on quantum behavior, the fundamental forces. These aren't just abstract ideas, they are the rules scientists use to model, well, everything.
From there, we move inward again, from the cosmic and the atomic to part 2, making a planet, Earth's formation. It's described as this massive, violent process of accretion, just dust and rock smashing together under gravity.
And all those collisions generated an immense amount of heat, so much so that the entire planet melted.
Which was a critical step, right?
Absolutely crucial, because that melting led to differentiation. The heavy stuff, like iron and nickel, sank to the middle to form the core, while the lighter rock, the silicates, floated up to form the mantle and eventually the crust we live on. That structure is what drives our planet today.
Which brings us to this huge intellectual fight to understand how old the Earth really is. For centuries, the estimates were just wildly off. Bryson tells a great story about Lord Kelvin, doesn't he?
He does. A brilliant physicist, Lord Kelvin, calculated the Earth's age based on how long it should take to cool down from a molten state. He was positive, absolutely certain, that the Earth could be no more than 20 to 40 million years old.
And that created huge problems for the geologists.
Huge. They were looking at rock layers and fossils, and they just knew that the planet needed these vast, unimaginable stretches of time, what we call deep time. But Kelvin's calculation was the accepted science. It terrified geologists like Charles Lyell.
So what broke the deadlock? How did they settle it?
Radioactivity. The discovery of radioactivity gave them the clock they were missing. It wasn't until radiometric dating was developed that they could measure the decay of elements in ancient rocks and get an accurate age.
Which turned out to be
About 4.54 billion years old. Kelvin's mistake, as Bryson points out, was that he didn't know about the heat being constantly generated by radioactive decay inside the Earth.
And this very old planet is also a very active one. The book dives into continental drift, plate tectonics, this constant motion.
It's the planet's engine. These plates are moving about as fast as your fingernails grow. But over millions of years, that slow-motion collision is what builds mountains like the Himalayas, or rips continents apart. It's the reason we have major earthquakes and volcanoes. We live on a constantly churning surface.
Which leads us right into part 3 and the ingredients for life. Before biology could start, the chemistry had to be perfect.
That's right. The book lays out the prerequisites really clearly. You need the right elements, especially carbon for making long, complex chains. You need oxygen. And most critically, you need water. Its unique properties as a universal solvent make it absolutely central to all biological processes.
And this all sets the stage for the big mystery, how life actually started. Bryson describes early Earth as this violent, volcanic place with a completely different atmosphere. And that's the backdrop for prebiotic chemistry.
It is. We know the building blocks, things like amino acids, can form naturally under those conditions. But the book is very clear that the precise path from those simple molecules to a complex, self-replicating system is, well, it's still highly speculative.
There's no consensus.
Not at all. It's the gap between chemistry and biology. Did life start in a primordial soup or near deep-sea hydrothermal vents? There's the RNA world hypothesis, too. The main takeaway is we know the ingredients, but the recipe is still a mystery.
And that journey toward understanding, wrestling with the questions, that's a constant theme of the book. It's not just about the answers. It's about how we search for them.
Absolutely. And for anyone who appreciates that kind of deep exploration, whether you're trying to grasp these ideas or you're maybe an aspiring author looking for inspiration, we should mention our channel. It's called Mindful Moments. Our YouTube channel offers AI book analysis, summaries, and critiques. It's all designed to inspire reflection and rational thought, and it's also really valuable for aspiring authors.
Okay, let's jump into the evolutionary arc. So, life gets a foothold. And for most of Earth's history, the book details how it was just these simple single-celled organisms, bacteria and archaea. We tend to forget that visible, complex life is just the very end of the story.
For billions of years, that was it. And then came the single most important event in life's history, the evolution of photosynthesis. This little chemical trick performed by microbes started pulling carbon dioxide out of the air and pumping out a waste product, oxygen.
And Bryson describes this as basically an apocalypse for everything alive at the time.
Wait, so you're telling me that oxygen, the air we breathe, was originally a catastrophic pollutant?
That's exactly how he frames it. Oxygen was a violent poison to the anaerobic life that dominated the planet.
It caused the biggest mass extinction the world had ever seen, a toxic, deadly atmosphere. But that very catastrophe is what paved the way for a new, much more efficient kind of metabolism, one that could power complex, multicellular life.
From there, the pace picks up. We get complex cells, then multicellularity, then life moves out of the oceans onto land. And we see this diversification into fish, amphibians, reptiles, a parade of innovation.
But it's a parade that's constantly interrupted by violence. The book really emphasizes the role of mass extinctions. These events, whether from an asteroid impact or massive volcanic episodes, are like a reset button. They're destructive, of course, but they also clear the slate, opening up new opportunities for other groups, like mammals, to finally have their moment after the dinosaurs were taken out.
Which brings us to part 5, the human story, and our shockingly late arrival to the party. If you compress all of Earth's history into a single day, modern humans don't show up until the last few seconds before midnight.
It's astonishing how brief our time here has been. The book quickly summarizes our origins, tracing the evolution of Homo sapiens from earlier hominins. Traits like bipedalism walking on 2 feet, and our growing brain size. But civilization itself, things like agriculture and writing, that's just the final fraction of the final second of that metaphorical day.
And our place here is pretty precarious because the planet itself is so volatile. The book dedicates a good amount of time to natural hazards, earthquakes, volcanoes, tsunamis.
He uses these powerful examples, like the eruption of Krakatoa in 1883. It made a sound heard thousands of miles away and cooled the entire planet for years. It reinforces this idea that these aren't rare events, they are inevitable. We are essentially just passengers on a geologically restless sphere.
And the book's conclusion links those natural inherent risks with the new ones we've created ourselves. He looks at things like rapid climate change and biodiversity loss, placing our short-term decisions against that backdrop of deep geological time.
It really hammers home the core themes, the sheer improbability of humanity and how fragile our civilization is within this much bigger, longer story. It frames our current challenges as very immediate problems set in a much, much longer context, which really underscores our responsibility.
So when you pull back, what's the lasting impression? I think it's the style. The anecdotal storytelling, focusing on the personalities and even the mistakes of the scientists, makes these huge topics so memorable. It feels less like a science book and more like a book about scientists.
I agree. The synthesis is that knowledge is a very human process. It's messy, it's iterative, and past certainties are often proven to be wrong or incomplete. It shows that what we know is built on a foundation of curiosity and a lot of hard work.
And the book leaves you with one final, really provocative thought. Just consider the sheer contingency of it all. The fact that countless chance events, the right elements from the Big Bang, the asteroid that wiped out the dinosaurs, the right conditions for life to even start all, had to align perfectly across billions of years. For you, the listener, to be here right now learning about it, that might be the most staggering discovery of all. Click the link on screen for the in-depth book critique. Subscribe, share, purchase via link, and think rationally.
See the many genre-based book podcasts at Mindful Moments. Subscribe and nourish your mind on the go.